am Rica Ruado.
And I am Diether Tolentino.
We are here to present our design project entitled Non-Controlled Electrical System. For the introduction, the system design is entitled Non-Controlled Electrical System, which is a process of controlling the power system in one place by deploying appropriate instrumentation and controlling the system. By adopting modern technology, managing and controlling the electrical connection will be done in a much faster way using networks and microcontroller. This will decrease the amount of time consumed by the personnel in managing power supply. The operator will control the entire system via computer or software. The software or application that will be installed on laptop or computer will allow the control of the system. With the use of the software, the user will turn on and off the electrical supply. LAN-controlled electrical system was developed by the researchers with the use of different electrical components. The main component of the project is the microcontroller, which serves as the main brain of the system design.
Objectives of the study. The study aims to develop the LAN-controlled electrical system. Specifically, it aims to design a system that controls the electrical supply of the different area in the school or buildings using network and computer. Develop a system that can reduce the number of time consumed by the personnel in turning on and off electrical supply using LAN, microcontroller, and solid-state relays. Evaluate the project in terms of functionality, reliability, safety, and ease of use.
Significance of the study. The LAN-controlled electrical system can help the following. First is the utility personnel. The utility personnel will benefit more from the project. The system can help in turning on and off the electrical supply in control room. Thus, manpower and time consumed will be reduced. Next is the street and park management. Electrical system in street and park was not totally monitored by the assigned personnel. There are many instances wherein lighting on streets and parks are always on, especially in daylight, or sometimes not on in nighttime. Consequently, street and park management will also benefit from the system. By using the system design, the lighting system in the said area will be monitored and controlled in only one place. Thus, more manpower will no longer be required. The third one is the small big companies. The system will benefit the small and big companies in order to manage the electrical system of the company. Manpower is required to do the task. Through the help of the system, the company will reduce the labor cost and lower energy consumption. It will also provide safety management to the employees and personnel. The last is the future researchers. In building the system design, the future researchers will enhance their skills and knowledge about the technology that they are going to use in a similar study. They will be aware of the new trend of technologies as well as the significance of it. They will be motivated to do the best for their future career by encountering different struggles during project making.
Scope and limitation. The LAN-controlled electrical system is much faster than the manual use. It will reduce time, allowing the personnel to do another task, and it will allow the personnel to manipulate the flow of electrical supply in a particular area using a computer or laptop. In order to connect or control the entire system, the personnel must connect its laptop or computer to the network that connects the microcontroller via LAN cable. The electrical supply must be connected in the system in order to monitor and control using the system. The system cannot control the physical circuit breakers but only the output of it.
Chapter 2. Review of related studies and literature. We have foreign literature, local literature, and related studies. For the foreign literature, the first one is the PC-based electrical load control by RS Electronics in year 2014. Next is the home automation system design by Embedded Staff in year 2016. The third one is the overview of automation systems and the home appliances controlled using PC and microcontroller by Kadimiti Haricharan in year 2016. For the local literature, we have the development of an automated control for household electrical system by Engineer Aristotle F. Musni, MIT, in year 2015. For the related studies, first is the embedded web server for home appliances by Diether Tolentino in year 2016. And the last one is the Bluetooth remote home automation system using Android application by Rica Asri Ramli in year 2013.
Technology use. In order to develop the system design, the following technologies will be used. The first one is the Arduino Uno. Arduino Uno is an open source microcontroller which can be easily programmed, erased, and reprogrammed at any instant of time. The next one is the Arduino Ethernet Shield. Arduino Ethernet Shield allows an Arduino board to connect to the internet. It supports up to 4 simultaneous socket connections. The next one is the LAN switch. LAN switch is a network device that cross-connects clients, servers, and network devices. The fourth one is the circuit breaker. Circuit breaker is a mechanical switching device capable of making, carrying, and breaking currents under normal circuit conditions. Solid-state relay. Solid-state relays. These are switching relays that do not require the use of any mechanical parts. Solid-state relay is much faster than electromechanical relays. And the last one is the Arduino IDE. Arduino IDE, it is an official software introduced by Arduino.cc that is mainly used for editing, compiling, and uploading code in the Arduino device.
Next is the conceptual framework. The figure represents the process of LAN-controlled electrical system. The first process is the user will connect the laptop or computer to the network and enter the username and password. Next is the user will select the circuit breaker that needs to control. And then the microcontroller receives the command through LAN. And the microcontroller executes the given command and control the solid-state relay. Conceptual paradigm. The figure shows the conceptual paradigm of the project. The diagram contains input, process, and output of the study. For the input, we have the hardware and software. First, the hardware consists of Arduino Uno, Arduino Ethernet Shield, PC, electric power circuit, and electronic components. For the software, we have the Arduino IDE, Notepad++, HTML programming language, and the C language. For the process, we have the problem identification, research, requirements specification, concept generation, design or the system flow, prototyping and construct, system test, system integration, and evaluation. And the output is the LAN-controlled electrical system.
Chapter 3. Methods and Procedure. In this chapter, we will discuss the methods and procedures used, the software and hardware including the different components used in order to develop the LAN-controlled electrical system. The figure shows the descriptive overview of the design process. Engineering design process is the process of devising a system component. The first one is the problem identification. Having a large area which needs monitoring of electrical supplies in different buildings and its parts are a little bit time consuming. Having to go to a certain area or sometimes climb just to shut down the electrical supply consumes time. The system may help the personnel to control the electrical supply. The next one is the research. To develop the project, the researchers also gathered some unfamiliar components. By reading different books and articles, magazines, and browsing the internet, the researchers gathered more information. The researchers also asked questions to the appropriate personnel on how controlling the power supplies works. The researchers also asked some professionals with knowledge about this field on how to work with electrical circuits and supply. Other existing projects and diagrams are also analyzed to get some ideas on how to construct the LAN-controlled electrical system. Requirement specification. The researchers discussed and designed the features of LAN-controlled electrical system. The system must be able to control the electrical supply in a certain building, and also the system must be user-friendly. It has LAN switches where the computer and microcontrollers are connected. The LAN-controlled electrical system uses 12 volts power supply for the microcontroller and also a power supply for the network hub. Concept generation. The researchers concluded that controlling the power supply in a certain place requires time just by walking, and sometimes personnel needs to climb. By that reason, they analyzed the situation and observed the current operations. They asked the professionals on how to automate the manual process. With the help of ideas gathered, the concept of LAN-controlled electrical system was created. Design. The design phase encompasses the layout or blueprint of the project, such as the design of the project, mechanical section, software design, system block, diagram, and flowchart. In this phase, the researchers will iteratively develop a technical solution, particularly to produce a detailed system design. Under the design, we have block diagram of LAN-controlled electrical system. This figure shows the inputs and output of LAN-controlled electrical system. The input of the system is coming from the computer, which sends the command to the microcontroller. It will send by a local area network to the microcontroller. The state of the solid-state relay is the output of the command sent to the microcontroller.
Letter B, the system flowchart. The flowchart explains how the LAN-controlled electrical system works. To start the system, the user will log in on the web app or on the software. He must input the username and password. If the username and password is correct, the user will log into the system, and if it is incorrect, he will go back to login section and input again the username and password. After successfully logging in, the user will select a building he wants to control. When the user selected a building, he has an option to turn on or off the supply of a certain building, edit building name and add a breaker on it, generate code to upload in Arduino, or just log out and terminate the session. If the building's electrical supply is on, the user has an option to turn it off. If the building's electrical supply is off, the user has an option to turn it on, and if it turned on, it will send command to the microcontroller. Now if the supply was turned off, the command will send to the microcontroller. After receiving the command will execute. If the command is on, it will send the signal to solid-state relay and it will turn on and off. When the SSR was turned on or off, the user has an option to return home. If the user chooses to return home, he will go back to building selected section and repeat the process again.
If the user chooses to edit the building, he will be able to add a breaker and save the changes. If the user wants to generate the code, he has to choose the IP of the microcontroller. Copy the generated code of the program and paste it to the Arduino IDE before uploading to the microcontroller. Then choose back to main menu. If the user chooses to log out the system, the user will go back to the login page.
Project design. The isolated view of the LAN-controlled electrical system. The next one is the front view. And the third one is the top view. This picture shows the connection of microcontrollers, solid-state relays, LAN cables, network hub, and circuit breakers The orientation and position of devices varies in where they will be installed and can be changed in accordance with the location. Letter D, the mechanical section. The figure shows the schematic diagram of LAN-controlled electrical system. The connection of each component are shown. The circuit breaker are connected to the solid-state relay, where the input of the solid-state relay are connected to the microcontroller. The microcontroller is powered by 12 volts power supply, and the PC is connected to the network hub, and the microcontroller connects to the network hub via Arduino Ethernet shield. And the circuit breaker supplied by 220 volts power supply. Software design, the Arduino IDE. The picture shows the software environment that was used by the researchers, the Arduino IDE. The codes were uploaded using the USB port of the personal computer to the port of the microcontroller unit of the project. The next one is the Notepad++. The picture shows the software environment that was used by the researchers for the web page, the Notepad++. This was used to program the software that will be sent commands to the microcontroller through LAN connection.
The next is the prototype and construct. The researchers searched for the components to use in order to build the system. They familiarized the major components, especially the microcontroller and components for the control panel section. They also conducted the research about programming language that they use. Watching tutorials and by reading some articles also helped them to get some ideas about the system. Hardware and software integration. To fully develop the LAN-controlled electrical system, all parts were assembled properly. For the software, research used the latest IDE to generate more features in terms of programming. Notepad++ for web page setup. The researchers finalized the list of materials needed and gathered them together. System integration. During the system integration, all of the subsystems were brought together to produce a complete system. From researching the components and planning its features, LAN-controlled electrical system was developed. And the system test. In this section, the researchers tested the system if it meets the desired output. It will also show if it meets the objectives and can perform according to its function. And the last one is the evaluation. System was evaluated according to its reliability or if the system functions according to its purpose. If it is user-friendly and safe to use. Safety criteria describes the protection of the user during implementation. The system design was evaluated with a total of 30 respondents. Chapter 4, Project Design, Testing, and Evaluation. This chapter includes figures and diagrams associated with the overall design of the project. Evaluation of the existing project. Different methods were applied for the successful development of LAN-controlled electrical system. Related studies and literature help a lot to plan and generate the concept of the actual design of the project. This has contributed a lot to the success of the design project. Next is the design consideration. In order to design the project, the researchers considered the cost, specifications, and availability of the materials to be used. The researchers used the newly encountered materials. Likewise, the time, reliability, functionality, ease of use, and safety were also taken into the considerations. Next is the electronic assembly. To avoid unnecessary mistakes such as short circuit and components failure, The circuit tree of the project was arranged properly. Every component was labeled and aligned properly so the connection became easy to identify by the developers. So this is the circuit tree of the LAN controlled electrical system. Next is the mechanical assembly. The developers designed the main prototype of the system. The figure shows the final design of the project. Fabrication of mechanical parts and interfacing of electronic control. This section involves safety and proper use of every component. The safety of the device was also taken into consideration because most of the components were electronic materials, so they must not be exposed on heat to avoid overheating and possible explosion. The components were attached to wood for the safety of the user. Simulation, testing, and troubleshooting. The developers always encountered malfunctioning of the components. In order to maintain the functionality of the project, testing and troubleshooting had been done constantly by the developers before and during the designing of the circuit of LAN-controlled electrical system. In programming, trial and error was performed by the developers to solve the errors and problems that had been encountered. After troubleshooting, the developers fixed and implemented the final design of the project. For the project testing, before the implementation of the project, testing is necessary. To ensure the proper function of the project, LAN-controlled electrical system tested several times.
Summary of findings. LAN-controlled electrical system was designed to develop the process of managing and manipulating the electrical system along the particular area. In designing and building the system design, different errors and malfunctioning was encountered by the developers. In order to solve the problem, troubleshooting was done by the researchers. Like for example, the connection of the web application and the microcontroller. The web application cannot send data to the microcontroller in early trials. In order to solve the problem, the developers put a static IP address on every microcontroller that makes it easier for the web application to connect to the microcontrollers.
Conclusions. Based on the summary of findings and evaluation of the project, the following conclusions were listed. First, LAN-controlled electrical system manipulated the electrical system through the software that was installed in the computer. Manpower was no longer needed. Second, the system is able to reduce the number of time consumed by the personnel in turning on and off the electrical supply using LAN, microcontroller, and solid-state relays. And the last one is the project was evaluated in terms of reliability, ease of use, and safety. For the recommendations, based on the evaluation, our results and conclusions, the following recommendations were derived. The LAN-controlled electrical system is suggested to be plugged in to 220 volts DC supply energy, and the microcontroller might be plugged into 12 volts power supply to perform its intended task and to avoid confusions and malfunctions. The second one is the researchers recommended to use the accurate microcontroller like Arduino Uno or Arduino Mega with Arduino Ethernet Shield to give a better output. And the last one, the developers recommended the use of fixed computer server for easy accessing the system and avoid data loss from microcontroller. The next video will show you how LAN-controlled electrical system works. Good day everyone. I am Rica Ruado.
And I am Diether Tolentino.
In this video, we will present to you our project, the LAN-controlled electrical system. To design this project, we use different components like circuit breakers, the solid-state relays, the network hub, and the 12 outputs, which is the bulb and the outlet.
In order to make this project possible, we develop a program that will control the entire system.
First, plug it into 220 volts power supply. Connect the LAN cable to the laptop, press the switch to turn it on. In order to access the system, type localhost/dp and enter. In the program, there is a login page. Type the username and password, then log in. Here in the program, we were prompted to the control center where we can see building names and on and off buttons to control breakers output. We can also manage the breakers of buildings by adding or deleting it. The next is the map page. The map page is where you can see the cartoonized version of the map of MinSCAT. Click on the building and the control will pop up on it. Here, you can also control the supply coming from the breakers. The next page is the generate code. Here, you can select the IP of the Arduinos and generate code to upload on it. Now, let us show you the system design's output. To add a breaker on a building, on the control center, click Manage Breaker on the selected building. Type the name of the breaker and relay name. Save it and go to the Generate Code page. Select the IP of the Arduino where the buildings belong. Click Generate Code, copy and paste it to the Arduino IDE. Upload and connect the solid-state relay on the given output pin of the Arduino.
And that's all. Thank you and God bless.